Okay, so for the lab part, there will be a lot of config, routing, routers and switches and servers. You will see everything, it will be in here, and too much config will be there. So let's establish my network by installing 3 end devices and connect them together using a switch. This switch will be connected to a router that should lead us to the internet. So this is the router that should lead me to the internet, and to lead me to the internet it should lead me maybe to the router of maybe google.com, and google.com, to make use of them I will make use of their server, which is maybe 8.8.8.8, which is their DNS server. So this will be private connected to a public, that's connected to a public, and again to a public, and let's see the difference about NATing and what will happen using static NAT. So connecting them together will be this way, of course, should be logical. This way you are free by using either DHCP to assign IP addresses to these devices to practice DHCP, sorry, even more, or you can just assign them statically like I will do now. This one and this one in here. Okay, so start by the computers, which are the simple part of it. For computers, let's agree both of us on the network. This will be a private network of a rare network. Let's make it 16.172.16.100.0, and just to manipulate this, let's do some subnetting with 25. Okay, this way. Of course, there will be a public subnet between my router and the world. This is a router of maybe google.com or whatever company. Okay, actually we're doing 8.8, so it's google.com, so let's go there and buy a public IP address, which will be 100.100.100.0 slash, how many IP addresses do I need? 3 for my PCs, 1 here for my router, and even more. Let's make it also 25. Yeah, we do have money, why not? And finally, for this one it will be 8.8.8.0, and we will make it slash 30. No, we have 4 8s, then we will increase, we'll make it also slash 25 for all the network to use in here. Okay, so starting with this first device, I will make it 172.16.100.1 will be for the router, this is logical, and let's start from .10, 11 and 12. So .10, it's not a class B, it will be 255, 255, 255, and by doing subnetting I will use only the first number after 24, so it will be 128 as a slash of 25. I believe you know how to do that. 172.16.100.1 is the default gateway. Good. And for you to have 17, why did I jump to the third one? I'm sorry. Okay, let's give it the third IP address or whatever. Desktop 16 100, was it 10 12? Yes, 255 255 255 128 172.16.100.1. Oh god, a bomb would happen. Is that .10 or 11? Let's make it .11. I don't like .10. Okay, and the third one will be .12. .13, sorry. 13. 255 255 255. I hope you are faster than me. I have finished it by the initial config. Will be good indication. that initial config is now ABCD for you. My first router should have enable configure terminal, have interfaced fast ethernet 0/0, which is the one facing my private network. It will have the IP address of 172.16, sorry, .100.1/25, which will be in this way. Please no shutdown, and that's all I need for this interface. Exit. Interface fast ethernet, the other one which will be fast ethernet 01. It have the IP address of 103 times, let's make it .1 from my side. It's also /25, no shutdown. Yes, I thought I have something mistaken for this one. CLI, no. Have two interfaces. Fast Ethernet 00 is facing my own router, which will be IP add 103 times. No shutdown. Exit. Fast Ethernet 01 is heading for Google service or server. I'm sorry. Should have the IP add of 8.8.8.1, and it's also /25. Okay, this good little server in here. This is how a real server looks like. An Ethernet adapter, some drivers, and some hard disk drives. Okay, so go to the desktop of the server after installing maybe Microsoft Windows Server and assign 8.8.8.8 to it. It has /25 and heading back to 8.8.8.1. This is step out of 3 steps in configuring NAT. The first step is configuring the initial config, which is only IP addresses, subnet masks, gateways, and no shutdowns. The second step, you should tell it to me, or you should have it think about it before I even say it right now, which will be routing. So I will use OSPF between them, since it's the only dynamic routing protocol mentioned here. I will use a stick, I'm sorry, what stick? I will use a trick in OSPF, which will be a router OSPF1. I now should advertise this network and this network together. I don't have the time for that because I don't want to, because it's not a real practice in a real company. It's only some lab, so I will advertise everything with the subnet mask or wildcard mask of everything in area 0. Everything for everything. Just route whomever wants to go to anywhere, just aid him without any further questions. This is done by giving all zeros with a wildcard mask of all zeros. And in the other one also, router OSPF process ID 1. Everyone please having whatever wildcard mask beneath and area 0. Wait for the OSPF message. Please show IP OSPF neighbor. Why? I just did OSPF1 and the other one. Don't tell me just because I did not make an end in here. Show IP OSPF1, show IP OSPF neighbor. Okay. No, this doesn't make any sense. Router OSPF1. This must work. 16.100.0 0 0. What do we have mistaken here? It's 127. Differentiate between 255 minus 128 will give 127. Of course, it will not give an even number. It's an odd number. So this first network and the other network will be, sorry for this convenience, but just doesn't make any sense. Let's see, what do I have in here? Send the two-way. It's stuck in the two-way. It's a point-to-point connection. Now it's X start. Checking the MTU. Now it's full. The 4 zeros should have worked. Now it's able to reach the other networks. If I just pinged any one of my networks, which was 100 maybe .11, it's pingable right now. So if you want the truth right now, what's happening between all the devices is that there is a reachability between this computer and this one, but by using private IP addresses, which is something that's not allowed to be done at all. So this PC in here right now just can normally do ping for 8.8.8.8, which is this one in here. Now it's reachable thanks to OSPF. First time on this one for negotiation, and the others are coming in here. So by doing it again, you can see that all the 4 requests are sent, all of them are received, no loss at all. But this big problems that I'm using my private IP addresses in here to send it to this one. So step 1 was initial config, step 2 was routing, step 3 will be NATing, and NATing will be done on my router, of course, not on this router. So for NAT, okay, so now let's start the NAT, which will be static NAT. This lab is for static NAT only. Static NAT is by mentioning that this specific private IP address, please translate it to this specific public IP address. This other private one, translate it to this other public one, and so on. I have for now 3 devices, 3 private IP addresses, so I will translate all of them to public IP addresses. Also for the IP address of this router, which is this interface, okay, just in case I needed some ping for the internet using this interface as a source. So I have 4 IP addresses to translate from private to public. This is done by the command of ipnat inside, for the inside of my company. The source static, which is the source I'm using, is static. If I deleted static and see the available options, it's either a list of addresses or the static. Okay, so let's make it static, and I want to translate the IP address of 172.16.101 to the IP addresses that I have bought. Let's make it 100.100.100. Just go on here, maybe starting from 10, 11, 12, and 13, because .1 I have used it on this interface. Okay, and that's it. And again, let's do the .11 to make it .11, and statically make the second one .12 to become .12, and .13 make it .13. Okay, so this is the statically NATing your 4 private addresses for for public IP addresses. Now let's do the ping command again and see if it will go out using the private or the public. Ping 8.8.8.8. It's pinging normally, but I have no idea it's pinging using which IP address, and to know that, go back to my router and do the command show IPNAT translations. Okay, so what's happening is that this router is receiving requests from the inside local, which are 172.16.100, this one, okay, and it's been translating to 100.100.100.10 in this way, okay, but there is something missing in here, is that it doesn't tell me it was heading to whom exactly, because of something missing that I have configured, which is in NAT you have two things to configure: NATing and the status of your ports, which port is inside, which one is outside. Okay, I did not do that. This one, if you had just noticed the command that I have issued a few moments ago, it was IP NAT inside. It means that I'm doing NATing for the inside. Who is the inside? Okay, as a word, when you use this term inside, you mean inside my network, my company. Okay, but the router needs to specifically know who is inside. The router right now has two interfaces. One of them is the inside, the other one is the outside, but you need to do this manually. So configure terminal interface fast ethernet 00, which is this one in here. It's IPNAT inside. That's it. Exit. That's all I need. And for interface fast ethernet 01 heading to the outside of the world, it's IPNAT outside. I'm sorry. Okay, that's all I need to know. So again, after submitting a ping, okay, no, so we will have lost the ping. Yes, please don't do this again. Yes, after submitting show IPNAT translations, now everything is clear. Can see the new statistics is that 172.16.100.13, which is my computer, sent the request, sent 4 requests. All of them were translated for, you can see now ICMP means a ping. Okay, all of them were translated to 100.13, and it was heading to 8.8.8.8, which is a public and doesn't need another translation at the side of google.com or the 8.8.8.com. I'm sorry, the site. So this is the complete statistics that you need to know about NAT. That's the first command. The other one will be show IP NAT statistics, I believe. This will show you that which interface is the outside, which other one is the inside. You can troubleshoot it from here in case you were misconfigured. Okay, how much hits and misses have happened. This is for the previous mistakes, and right now the 4 statics have done. Okay, so these are some statistics that you need to know about NATing. So 3 steps must be done. The first one is to do the, I'm sorry, what was about it? The first one is to do the initial config. The second one is to do routing. The third one is to do the what's called NATing. NATing has 2 steps. Step number 1 will be the two interfaces inside and outside. For this router, this interface is inside, the other interface is outside. This is manual done. The other one is to do IP NAT inside source, this one, IP NAT inside source static, this one, and so on, to statically NAT your IP or private IP addresses to become public IP addresses. This is static NAT. In the upcoming lab, I will just start directly with the dynamic NAT, okay, of the groups. I will not start from initially or doing anything. The initial config will be the same. The OSPF or routing will be the same. Also, nothing will be changed. Only the criteria of NAT will be changed. Also, the inside and outside interfaces of NAT will be the same. Only these few commands of this one, these 4 commands that I have done for a static NAT. I will delete these 4 commands. I will show you how to delete them. Okay, I will delete these 4 commands. After that, I will establish dynamic NAT. Okay, so I hope static NAT is clear to you. Just in the upcoming minutes, I believe I will merge it with this one. I will start the dynamic NAT. So just if you like, take a rest, and after that we will continue with dynamic NAT.